When it comes to what I say, the questions in organic chemistry in the JEE this time, they have asked very detailed, good questions where you have to really see all the connections through. So now, when it comes to organic compounds containing oxygen, all right, alcohols are obviously going to be up top. Then you get phenols. Then you get ethers. This is generally focused in one chapter. Then you have your aldehydes and ketones. Now, you've already gone through a bunch of reactions of each of these already. Not necessarily a large number, but a few of these already. So let's start by putting them together first. You, of course, also have among the other ones carboxylic acids and acid derivatives. But that is for later. We will talk about them later. So for the time being, what I want you to do is very simple. You have already got some information about alcohols, phenols, ethers, and aldehydes and ketones already from the chapters which you have already covered in your organic chemistry. I want you to start putting them down now. Let's start discussing them quickly. First off, any reactions which you remember of each of them involving them. Let's start with anything. What comes to your mind first?
Alcohols, dehydration.
Alcohols, dehydration.
Hmm.
Okay, all right, so let's start off with that. The first one, dehydration of alcohol. Now, when it comes to dehydration of an alcohol, we did this in two ways over there. We discussed this as E1 versus SN1.
Yes.
I hope you remember this particular thing there. So you're going to be having dehydration of the alcohol over here. Let's say I'm going to be looking at the mechanism for this. The usual mechanism is carbocation formation.
Hmm.
So if carbocation formation is applicable, what does that lead to? That leads to rearrangement is possible, probable. In a sense, almost all the cases which you will be seeing this, they will give you with rearrangement. They will not give you without rearrangement.
Hmm.
Now, if I'm going to be having in this particular case here, E1 versus SN1, E1 is going to be favored at higher temperature. I think we had discussed this already, yes.
Yes, sir. Yep.
And SN1 is going to be favored at lower temperature range. Doesn't mean it is lower temperature, it is lower temperature range. After forming the carbocation. Now, next up is going to be the same dehydration of alcohol here can be done in many different ways here. So if it is to follow this particular carbocation formation and mech, you need to have something like a concentrated sulfuric acid and heating.
Hmm.
Or instead of concentrated sulfuric acid, you can also have concentrated
Yes.
phosphoric acid
Hmm.
and heating.
Okay.
And in some rare cases, concentrated HF and heating. All three of these work in similar ways over here, depending on what is going to be the scenario over here. Now, the dehydration of alcohol can also be done with other exotic reagents. All right. So when I say exotic reagents, I mean stuff like, say, Al2O3,
Hmm.
thorium dioxide, some random
W.
funny business type of shit. Depending on what is going to be the case, it might go for a different type of mechanism, resulting in a slightly different product. So that you'll have to basically confirm based on what type of data is going to be necessary, depending on the type of exam you are considering also. If you're considering a JEE mains exam, you don't need to bother so much. If you're considering a JEE advanced paper, you more or less do not need to worry so much. But if you're considering an internal paper, yes, you might have to bother about these kinds of things. So you're going to be having dehydration of alcohol. Absolutely is going to be a fairly critical reaction. And you're going to be having in this dehydration of alcohol here, the E1 will result in alkene as a product obtained. And the SN1, what does that result in product?
SN1. Replace. Replace.
What will happen there? What is the product?
Alkene.
No, think.
What?
I have ROH.
ROH.
Correct.
Oh.
So what is happening over there? H plus first. We'll convert this into R OH2 plus 1.
Hmm.
Then next step, what will happen? This guy will leave.
R plus.
So this will effectively result in the formation of R plus plus H2O.
Hmm.
This R plus can now do E1, or this R plus can do SN1.
Hmm.
Right? SN1 now, what will be the possibility there? Some nucleophile has to come and attack.
Yes, it
This
can
is
be
my
alkyl
electrophile.
halide.
So what will be the
Hmm.
nucleophile which will come and attack? Another molecule of ROH.
Another molecule ROH. Hmm.
Correct?
RO will
Oxygen
come.
has. So what do I get?
Ether.
Yes. So you end up having SN1 gives you ether. So this is a reaction which you will be seeing in alcohols over here, which will also
Hmm.
be a preparation for ether.
Yeah. Okay.
Fair enough?
Yes. Yes. Yes.
Next, let's go
Hmm.
for the next reaction which you're supposed to be looking at, which you already had a look at. Give me another reaction. Any other reaction which you have learned involving alcohols, phenols, ethers, or aldehydes and ketones. Any one of them.
Hmm.
Don't think too hard. Go with the first one which pops in your brain.
For ketones and aldehydes, maybe Grignard.
Grignard, okay. All right.
Grignard is a nucleophile.
Let's directly go for that. So if I have an alcohol or an aldehyde or a ketone. So I'm assuming you're talking about this reaction, correct?
Yes, sir.
Reacting with Grignard reagent.
Hmm.
Correct? Huh?
Hmm. Yes, sir.
Okay. So now this reaction is going to be something where you'll be having the first reaction, of course, is going to be done in a manner where this is going to be a proper nucleophilic addition.
Hmm.
So in this particular nucleophilic addition reaction here, this CH3 here effectively ends up becoming something which has a fairly high delta minus. The CH3 will come and attack this carbon delta plus here. So when
Hmm.
it attacks the delta plus here, this oxygen, which already has two lone pairs, will take a pi cloud for itself. When it takes a pi cloud for itself, we will end up having product obtained here looking like this.
OCX. OMGP. MGX.
Okay. This fellow is then going to be undergoing hydrolysis in the next step usually to effectively give final product as RC. Now, the other product, of course, is MgXOH.
Hmm.
Okay. So when you're going to be having this reaction happening here, depending on what is going to be present as your R here or the R dash here and the methyl here, you can get different products.
Hmm.
For instance, if you start with formaldehyde, you'll be getting 1 degree alcohol as product.
Yes.
If you start with any other aldehyde,
2 degree.
yes.
Yeah.
And if you start with a ketone, you get a tertiary. Now, this is going to be a very straightforward reaction. And you're going to be having these as the products obtained in general over here during this reaction. Of course, as you can see here, this reaction is involving nucleophilic addition reaction here. So if nucleophilic
Hmm.
addition reaction is going to be happening here, when will the reaction go faster? Very simply put, if you're going to be having higher delta plus
Hmm.
and lower steric hindrance and stronger nucleophile
Hmm.
implies faster reaction. So obviously higher delta plus and the lower steric hindrance part will directly tell you which group, whether aldehydes or ketones, which one will react faster. Obviously aldehydes will react faster because they have a higher delta plus and they're also going to be having a lower steric hindrance. Formaldehyde will react even faster than the other ones there. And stronger nucleophile means you'll end up having a faster reaction.
Hmm.
So these are basically going to be the reaction conditions associated with this. And this reaction here is going to be something which is going to be effectively involving an aldehyde or a ketone becoming a stepped up alcohol, not the corresponding, but a stepped up. So in this case here, you can think of it as aldehyde or ketone gives stepped up alcohol. More carbon atoms. Now, if you want to get the same number of carbons, the same aldehyde converted into an alcohol, how would you do that? We talked aldehyde with Grignard reagent here, correct?
Yeah.
We got an alcohol. Now, if I want to get the same thing, for instance, let's say I'm interested in doing aldehyde or ketone, say R C double bond OH / R dash. I want to convert this guy into RC OH H and a H / R dash. What should I be doing over here?
Tautomerism.
I'm doing corresponding alcohol.
Yes, sir. Then
Stop thinking hard, think easy. So in the case of Grignard, we had a CH3 minus being going and attacking.
Hmm.
So in this
Yeah.
case, I need to have a goddamn H minus going and
H
attacking.
minus. Yes, sir.
Right? As simple as that.
Yes, sir.
So H minus, how do I generate it? From where? LiLH4.
That's what, yes.
NaBH4.
NaBH4. Yes.
Right?
Yes, sir. Yeah.
So you have to think in the same way. The reaction mechanism is going to be same, nucleophilic addition only. All right. So
yes, sir. Yeah. Got it.
mechanism is going to be nucleophilic addition as well again here. Meaning the constraints involved are going to be the same. Okay.
Delta plus, high delta plus. Yeah.
Now, in this here, LiLH4 and NaBH4 case here, we are going to be having some extra points to pay attention to here. If I have, say, let's say I have a compound like this. As you can see here, there is a conjugation available here. Okay. When you're having conjugation available, if you are doing LiLH4, or if you are doing Grignard,
Did not also.
or if you are doing alkyl lithium. Okay. In any one of these three cases, it will attack here first directly and will perform what is called as 1-2 addition.
Yeah.
Okay. Whereas if I took the same compound and I hit it with, say, NaBH4, or if I hit it with, say, R twice CuLi. How do you get R twice CuLi? That R twice CuLi you get by reacting this fellow with Cu2X2.
Yeah.
Okay.
Gilman.
So this is your Gilman reagent, correct? So you're going to be having this obtained over here. Similarly, I can also use dialkyl cadmium. That also does a similar reaction. Dialkyl cadmium, not so much. The other two are main fellows there. You can also have, instead of CuLi, you can also have R twice CuNgX. That also is perfectly acceptable. Okay. So in that particular case, what is going to be the product obtained over there?
Attacks the dogma. Conjugate.
Yeah, you're going to be having in this particular case here, the 1,4 addition is going to be obtained first, then 1,2 addition. Second equivalent will do 1,2 addition. Okay, so first equivalent will be 1,4 addition product only. Only in the second equivalent will you start getting the 1-2 addition happening over there. So you'll be having actually the 1-4 addition happening first with one equivalent. Then you'll have 1-2 addition with the second equivalent. So you're going to be having in these cases over here, slight differences in the products are going to be seen. You've noticed these reactions, you have seen these reactions till now, I suppose, yes or no?
Yes, sir.
No.
Yeah.
So this is again going to be a bunch of reactions which you have seen where, what to say, you learned it in Grignard reagent, I suppose. And you're going to
Yes.
be having these
Hmm.
also as reactions of alcohols or the reactions involving preparation of alcohols, which are of course reactions of aldehydes and ketones as well. Next up, what else do you know?
Hmm.
What else do you think connects with any reaction involving alcohols, phenols, ethers, aldehydes, and ketones?
Ozonolysis maybe. Sorry, sir.
Good. So ozonolysis is a reaction which you're familiar with also. Let's quickly brush through ozonolysis. Now, what was ozonolysis? Ozonolysis is a reaction where you're going to be having this as a reaction of what to say alkenes and alkynes. So when you're going to be
Hmm.
considering this reaction here, you're going to be having two steps. So you're going to be having in this particular case here either reductive ozonolysis is possible or oxidative ozonolysis is possible. Now, when it comes to oxidative ozonolysis, this is same as powerful oxidizing agent. No difference there. Whatever any powerful oxidizing agent does, the exact same thing your oxidative ozonolysis does. So the idea here is if I have a compound like this, nice big compound like this. All right. So if I'm performing oxidative ozonolysis here or reductive ozonolysis, let's find out what the products are. So in this case here, break every double bond and every triple bond.
Hmm.
Now, if it is going to be a triple bond and it is going to be only doing reductive ozonolysis, you don't need to break everything. You don't need to break everything in the sense you need to break only the triple bond here to an extent where the single bond is left over. So two bonds break, this breaks fully. Here also two bonds break. So you're going to be having in this particular case here, triple bonds are broken halfway, double bonds are broken fully. So if it's reductive ozonolysis, this will become a double bond O here, double bond O, double bond O, double bond O, double bond O. And here also this will break here. So another double bond O here, another double bond O here. And we'll be having these two locations and these two locations also gaining double bond O. That is going to be a product obtained when you're going to be having reductive ozonolysis. So what is the real product there? You end up having this as one product. This is one product. So you'll be having acetaldehyde. You'll have formaldehyde. And you'll have this becomes something like this. And this is going to be a very interesting species over here. So let's break this off completely because this will be one big part over here from here to here. From this part to this part will be one compound, and from this part to this part will be another compound. So
Hmm.
we're going to be having this being one compound, and this is going to be the other compound. All right, so let's break them down and put them down individually. So you're going to be having this guy being, whenever you're having an issue like this, put numbers down. So you're going to be having 1, 2, 3, 4, 5 being a long chain. 1 is going to be a CHO. 2 is a carbon like this, 3 is a double bond O, 4 is also going to be a double bond O, 5 is a methyl. And number 2 is going to be having another CHO attached to it. So this is going to be this compound over here. And the last compound is going to be this bunch over here. Let me put in black here. This bunch over here will come out as a compound. So this is going to be CHO, single bond C double bond O, single bond C double bond O, single bond CH. So this is going to be the compound in question over here. I think you understand the different compounds produced over here in this compound here. Yes?
Yeah.
So this is for reductive ozonolysis. If the same thing underwent an oxidative ozonolysis, this will become a carboxylic acid. This will become a carboxylic acid. This will become a carboxylic acid. This fellow will become oxalic acid, sorry, not oxalic acid, formic acid, which will not remain as it is because formic acid will also undergo further oxidation more easily to actually become carbon dioxide gas. And this fellow will become carboxylic acid. This will also become a carboxylic acid. Okay.
Yeah.
And unfortunately, it doesn't end over there. This compound here will become carboxylic acid. This species, this will also become carboxylic acid. And the problem is when you're going to be having a triple bonded type of location where you're having double bond O, they will also not remain intact, meaning this will also break here and so will this. Okay. So what happens over here is this will also become a carboxylic acid. This will also become a carboxylic acid. Same way, this will also become a carboxylic acid. This will also become a carboxylic acid. So we'll end up having in this particular case here, this entire bond breaks off over here. This bond also breaks off over here. Meaning we will have this coming out as one molecule. This will come out as another molecule. Meaning we'll be having this actually becoming two molecules of oxalic acid. Now, oxalic acid has its own issues there, but oxalic acid here will be obtained as oxalic acid. Same way here, this compound will become something where this will be one molecule. And this bottom part is going to be another molecule. So you get another molecule of acetic acid actually. Basically, this will become acetic acid also, which is same as this. So yes, complicated, irritating. And the idea here is when you're having a large molecule, oxidative ozonolysis is being performed. The idea there is very simple. Think of it as purely KMnO4 concentrated. What will be the product of KMnO4 concentrated? Put that down. As simple as that. So if there are triple bonds present, they will break completely. Both the corners of the triple bond will become carboxylic acid.
Okay.
You understand the idea here?
Yeah.
Okay. So ozonolysis, yes, this is going to be a reaction which is going to be connecting your aldehydes and alkynes with aldehydes and ketones, and of course with a little bit of carboxylic acid also. All right. What are the reaction? Do you remember connecting?
Oxidation is there, but then that's similar to ozonolysis.
Okay. What are the reactions other than oxidation? Oxidation is same as ozonolysis. Just now we talked about it. Any other reactions you remember? What oxidation do you remember?
With strong oxidizing agents and
Strong oxidizing agent is taken care of now. Next up.
like like I know like some specific reagents like
Talk.
Bayes reagent and then OSO4 and then
Good. So you're going to be having,
chromic acid.
yes, we can talk about diol preparation.
Okay. In chromic acid was for carboxylic acid.
Yeah, that is basically oxidation again.
Okay.
So diol preparation, you're going to be having, of course, if I have an alkene and I'm going to be doing two methods are applicable over here. What is Bayer's reagent? Can you give me the name?
Cold alkaline KMNO4.
Cold dilute alkaline KMNO4.
Dilute. That's what
So you're going to be having cold dilute alkaline KMNO4. So this is going to be a Bayer's reagent. When you end up doing this, you have syn attack on vicinal carbons.
So this is not the same as just normal KMNO4, right?
This is not the same as normal KMNO4, absolutely.
Hmm.
This is the weakest version of KMNO4. So in this particular case here, this effectively ends up becoming something where MnO4 minus generally ends up becoming MnO4 minus 2. This is your reaction actually. Okay. And in some even rarer cases, the MnO4 minus 2 might end up becoming MnO2. This is the maximum it can go up to. So syn attack, vicinal carbons, you'll be getting product obtained as this guy. All right. Or you can think of it as, instead of putting it like this, we'll put hydrogens over here. We'll call it a cis compound in the beginning. So if this was a cis compound in the beginning, I'll be having OH and OH, both from the same side. So if I have to draw the projection, it will look like this. This is going to be the compound obtained. So the same thing here can also be obtained by using a different reagent instead of this. What is the different reagent you can use? You can use osmium tetroxide followed by sodium bisulfite.
Okay. Yeah. It was.
Hmm. That is also going to be resulting in same syn attack, vicinal carbon. In that particular case, OSO4 is going to go from osmium plus 8 to osmium plus 6. Clear so far?
Yes, sir.
Why do
Yes.
you look like you're just letting time pass?
No, sir.
Okay, next up, what are the reactions? Do you remember?
Mm. Decarboxylation.
There is
But
carboxylic acid. Let's not go there yet.
okay.
Let's stick with alcohols, phenols, ethers, or aldehydes and ketones maximum. Seriously, nothing much else. There are a lot more reactions which you're supposed to be able to remember.
Mm.
Seriously. Okay, so let's say we are looking at acid-base reactions.
Mm.
Where would alcohols come into the picture here? Where would phenols come into the picture here? alcohol here, is it stronger than water as an acid or weaker than water as an acid?
Weaker.
Weaker. So this is weaker than water as acid. Correct. But that consequently also means RO
But
minus
base.
is stronger than
Stronger
OH minus as a base.
base.
Correct?
Yes, sir.
Phenol on the opposite end is going to be stronger than water as acid.
Yeah, that's
Okay. Now let us now look at some reactions involving these guys as acids. So if I have to involve these fellows as acids, what would be the reactions then? For phenol, this will dissolve in sodium hydroxide. Why? If it is dissolving
the
in sodium hydroxide, what will be the reaction?
phenoxide ion and
Good. Phenoxide ion मिल रहा है. That means you're actually having OH minus के साथ reaction
exactly.
is going
Yeah,
to be PHO minus plus
plus
H2O.
water. Hmm.
So this
Yeah.
is in the forward direction.
Yes, sir. Yeah.
So that means what really? That means I'm going to be having PHOH here is compared with water for
Which
acid.
is yes. Hmm.
And OH minus and PHO minus are compared with each other for
As
base.
basis. Hmm.
Whichever side has stronger will basically push it in that direction. So which
Yeah.
side acid is stronger? Phenol is stronger.
Phenol strong. Yes.
Which side base is stronger? OH minus is stronger.
Oh, it's minus strong.
So forward
The
direction, reverse.
reverse. Hmm.
If I did the same thing for an alcohol, what will happen?
Reaction will not take place because everything on right side is better.
Correct. So phenol dissolves in NaOH while ROH does not.
Sir, why did you write specifically NaOH?
See, instead of what is the reason why I took NaOH? Can you take a guess? What is the base over here which I'm operatively using?
Strong base.
No, OH minus.
Oh, I mean like yeah, dissociate NaOH minus. Well, I mean
Basically,
okay.
instead of NaOH, what else can I use? Any other OH minus type base I can use. I
KO.
don't give a shit.
Yeah, that's right. Okay.
CSOH, KOH are also perfectly acceptable. But I
Hmm.
can't use something which is a non-OH minus type of base.
Like ROH we can't use.
OH minus type of base, meaning
Why?
something which does not produce OH minus ions.
Hmm.
ROH, yes, is not an OH minus type of ion producer. You're not wrong. But ROH is not the example which I was looking for here. I was looking for RO minus.
Hmm.
You didn't understand shit.
Ah. Wait,
You've
wait.
gotten very good at this.
No, 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 sir.
Where have
Yeah.
you learned about RO minus? That's the next one I wanted to discuss anyway, which is another reaction you have learned. So this is the acid part over here. Okay. Next to base part. You have learned reactions involving RO minus as base, which you have
Yes.
forgotten. What is the reaction?
1 second, 1 second. Wait. That one. This one. E2. Yeah. Yes. Yes. CH. Hmm.
Remember now?
Yes,
This
yes.
is a
Yeah.
reaction involving alkoxide. So it does involve alcohols.
That's the one. Yes.
Okay, so you're going to be having in this particular case here, elimination reaction happening. So this is going to be happening here, resulting in two possibilities. Actually, I'll remove off one of these things. That is easier. Mm, yeah, now it is easier. Okay, so we're going to be having what to say, the product obtained over here is going to be this fellow. All right. So we're going to be having in this particular scenario over here, this is the product obtained here, and you're going to be having E2 elimination product being the alkene obtained straight away over here. So along with that, what will happen to this fellow? That is, this fellow would have become an ROH
Yes, sir. Yes.
in the process.
Hmm.
Okay, so E2 elimination involves an alkoxide as the intermediate over there as the basic medium. So RO minus provides the basic medium.
Yes. Right.
And stronger the basic medium, faster the reaction. Hmm. Okay, all right. Next up, what else have you? Where else have you come upon reactions involving these guys? What other reactions are you familiar with? You have come across a few more reactions.
Yes.
So if I'm going to be considering, say, electrophilic aromatic substitution,
Yes. Yes. That was okay.
you've definitely come across some reactions involving phenol over here because
Yes, sir.
EAS is going to be very common for phenols.
Yes, sir.
So you have a bunch of reactions involving phenols applicable. Now, other than this here, there is one other class of reaction which you have come across over here, which is the reverse, which is like ether hydrolysis. What happens when you take an ether and you heat it type? We have not discussed that separately, but you've come across it in some way or another here. Okay, now let's quickly start off with what to do now next over here. So far we have just recapped the reactions more or less which you have come across in different chapters. Phenols के लिए EAS reactions. When we discuss phenols, we'll sit and do that. EAS is a large set of category of reactions which phenols answer usually. Now, other than these reactions here, there are of course going to be specific reactions also involving each of these groups, which some of which you would have touched upon, some of which you definitely have not yet discussed. So, do you want to start discussing these reactions, or what exactly is your plan with respect to organic? Do you want to basically just touch upon this kind of thing where we discuss the parts where they are going to be connected and stop at the connection stage, or do you want me to progress forward and then see how things go? I have no problem with moving either way. I think as of now, thermo is completed for you, right?
Yes, sir. Yeah.
And we can continue on with physical chemistry also. There are two more. There are actually what? How many more chapters there in physical chemistry for you? There is
Mole
liquid
concept.
solutions, chemical
Oh,
kinetics, electrochemistry,
that's it.
and
Gaseous state
surface
slightly.
chemistry. Gaseous state is okay. That's not required really. Surface chemistry and solid state.
Hmm.
Five are there. And solid state is not that complicated. Once your school they start doing it, we can wipe it out as well. Solid state is there in your school still, or it's not there?
Not
Not
sure, sir.
sure. Not sure. Okay, all right. Surface chemistry is fairly straightforward. There's nothing much anyway in that. That leaves the main three chapters: solutions, chemical kinetics, and electrochemistry. Solutions should be okay. Chemical kinetics should be okay as well. Electrochem will be decisive. Um, Organic भी बाकी है. Inorganic. Okay. How is your what to say ability to absorb information now? What do you want to go with? Should we continue on with what to say organic reactions, or should I start off with another physical chemistry topic?
Mm,
Because we are at a stage where we have brushed up on everything which we can brush up in organic, necessarily
yeah.
speaking. Abhi say I'll have to start going into uncharted territory. So, what's your thought here? Because if you have enough ability to basically absorb and you feel like absorbing a good amount, we can go for physical chemistry and finish off a chapter itself. Because that is obviously going to be more beneficial in the long run. Organic chemistry, you'll anyway be coming back again. It's like थोड़ा अंदर जाना है, थोड़ा बाहर जाना है, थोड़ा अंदर जाना है, थोड़ा बाहर जाना है. Organic is always better that way. So, what's the situation like? From what I understand, you will be having holidays up till at least one more week.
Max. Yeah.
Max नहीं मिलने वाला है. Hostelers तो आए आने वाले नहीं है definitely, but day scholars mostly might start showing up from next week onwards. Correct? Next
Yeah.
week
I guess.
midway.
Maybe. Yeah.
So, what is the situation like? What do you want to do? School में भी क्या करने वाला है? Any idea? Any information?
Sir, I'm pretty sure they'll start organic again.
Hmm. Okay, are you sure?
Pretty sure. Not
Pretty
exactly too
sure.
sure, but sir, I'll check the workbook actually. 1 second. Should I?
Hmm.
Uh, just a second. Sir, we have alcohols, ethers, and phenols, carbonyl compounds, and carboxylic acids and its derivatives.
So organic
Yeah,
for phase
that's
five.
what's yeah for
Phase six
that's
is
what's in the workbook.
physical chemistry. Is it?
I guess.
Hmm. Okay.
Yes. Yeah.
So we are anyway going to be going into organic soon enough once your school starts. So what do you want to do? How much tolerance do you have?
Sir, I think if we do a physical chemistry chapter, that'd be better.
Obviously, I am leaning towards that direction, but that
But
doesn't mean I want to force your choice here. So think about it for a bit. We will close the session here today. Let's not probe any further for today. Uh, you go through organic once more and you make a decision, because if you feel, what to say, you have gained reasonably enough confidence in organic and you have got like good amount of momentum built up so that you can start continuing and working, go ahead, no problem. We will go into physical chemistry a little bit and come back. Or if you feel your organic momentum is not enough, where you feel like, what to say, thoda painful hi chal raha hai, and you would like a few extra leg up type of things, where like a little bit of the topic we actually cover in advance before your school is also finishing off, and we spend a lot more time on organic. But why I am not favoring that option is mainly because you do not have that kind of luxury in terms of time. Sincerely, दे सकते हैं time, but it will come at a cost of something else. That is inevitably going to be the reality, because if they are going to be spending more time on organic now, they will be rushing through something else later.
yeah,
Most probably inorganic is what I'm guessing. They will probably just not touch upon it. Last phase will be seventh phase, which will probably be in like say
eighth phase.
November. Eighth phase. Eight phases hai kya abhi?
Yeah. Yes.
They changed it. Okay. Okay. Seven phases is what it used to be. So four and four now.
Fourth phase. Sir, I think like since we're doing like specifically mains now, I think the organic like till now, I think will that be enough for like mains level? Like, what do you think? Because according to that, if you see, I think doing physical chemistry to be better,
No,
mains point
I
of view. But
agree with you from a main. That's why I'm saying it is not that bad. Your level seems to be acceptably decent for mains. Advanced, you are not having much of a sight as of now, obviously, but advanced is going to require a lot more in organic chemistry because the game is really serious in advanced papers right now. The type of questions they've asked in organic are fantastic. Even if you knew everything well, it'll still be tough questions. Simple as that.
so
Yes.
it's far beyond NCRT or like still.
Yeah, far beyond. Advanced than you're asking,
Yes.
far beyond. As in, flat out far beyond. There's
So
no
like
question. Yes.
in NCRT there are these tables of like numbers and all, right?
None of that shit will be useful beyond a point.
That's not useful, right? Yeah.
They'll be useful up to a point. See, think of things like this.
Patterns and trends are like that's enough, I guess.
Ah, that is all you get from NCRT. That will not be enough for advanced in any way. Advanced requires proper real game, real organic chemistry you require. So at least this year's paper has clearly shown that.
Mm.
Inorganic chemistry also advanced seems to be requiring a good level, but not too shabby. It's doable type. But organic, they have really upped the game. You really need to have like really good subject in organic to make a decent dent, sincerely. And that is basically where things are as of now. Things are standing here. And hmm, physical chemistry does seem like a better option simply because, from a JEE mains perspective, yeah, organic chemistry, you don't have too much of a problem. You're reasonably comfortable there. Advanced, it's too early to comment, so to say. So, mains is what we'll focus on. From that perspective, yes, I would say that going with physical chemistry, covering off one more topic will definitely be helpful.
So
And
till
yes,
mains level or advanced level as well.
physical chemistry, there is no
Nothing.
real mains and advanced level differences which are pronounced. The differences are more pronounced in organic. Physical chemistry, the differences are pronounced only in one or two chapters, namely thermodynamics
Thermodynamics.
and what to say, electrochemistry. These are the
Okay.
two topics where the differences between mains and advanced levels will be very clearly pronounced.
Hmm.
When it comes to the other chapters, it is not that different. In the sense, they are very much the same. The advanced might be more calculation intensive, more like what to say, you solve one problem, you solve another problem, then you combine the two and then get another answer. But not too much thinking involved. That type might be there in advanced over here. So theory wise, they are more or less the same. Not much in terms of difference in terms of theory. Problems
And
are also going to be relatively the same in most of the chapters. Advanced will be slightly more trickier in a few of the topics here, but much trickier only in mainly two chapters. Thermodynamics will be much different in advanced, and electrochemistry also can be much different.
so how long will it take finishing now?
Depends on the chapter, obviously, but
I mean, yeah,
what to say,
whatever you're thinking.
surface chemistry will take like maybe 3 sessions, 2 or 3 sessions maximum. Solutions will take like say 4 or 5 sessions at least, and kinetics will take another 4 or 5 sessions at least. Electrochemistry, I'm not even going to bother touching up right now. They'll take a lot more, so we will come back to electrochemistry a little bit later. Once there is
Hmm.
enough maturation time available, then we'll come to electrochemistry eventually. So,
Yeah.
around anything or everything which we'll start will require like 4 or 5 sessions. I'm looking at solutions or chemical kinetics
So-
mainly.
okay. Hmm. Will that
Uh,
be linked up to solutions be linked up to thermodynamics as well?
Solutions will be linked with a little bit of equilibrium and a little bit of stoichiometry.
Okay.
It
Okay.
doesn't have much link with thermo. It has some links with thermo, but not much. Okay, we will close here today. Then mostly I will start with solutions tomorrow. Then I suppose that works for you.
Tomorrow.
That's what you're asking. Yes.
Yes, sir.
But have a look at your organic also once more. And my recommendation is, for the time being, have a look at your organic chemistry questions, PYQs, mains wala.
Sir, I've done them. I mean, for the preparation already
And
last
you're
time.
comfortable with
I
them?
can go through them. I'll do them again,
No
sir.
need to
I'll
do
go
them.
through
I'm
them again.
asking if you're comfortable with them. I wanted to know the analysis there.
I mean, I'll go through them again, sir.
Fair,
I
fair,
mean, I don't exactly
fair.
remember.
Okay, cool.
Sir,
Okay.
I also
Mm,
the Himanshu Pandey book.
mm.
I told, should I practice that? I have time, like that has a lot of questions.
That actually will not be a bad deal.
If so, which chapter? Because I think I'll be able to do all of them. Even like
Pick the ones where you were not confident in. Hydrocarbons, definitely.
I don't, yeah.
No, I'm not kidding. I'm serious.
Yes, sir. Yeah.
Hydrocarbons,
See.
alkenes, you definitely should do. And alkyl halides, maybe up to you. You decide. Hydrocarbons, definitely.
Okay.
Anything else? What else is troubling as of now? Anything else on our table right
That's
now?
nothing else, sir.
Okay, then dude,
Nice
we'll
one. That's
close up for today over here itself.
sure.
And we will come back again, say tomorrow or day after. What time?
No worries, sir.
I mean, normal morning also works, I suppose. No?
Morning, fine, sir. Yes.
See you. Bye bye.
Yeah. Thank you, sir. Have a nice day, sir.
Have a nice day, dude. Bye bye.